It's our 11:30 press conference, which we've entitled, What's Going On in the Arctic? This press conference is about the release today of the 2012 Arctic Report Card, which is sponsored by NOAA. Our speakers are Dr. Jane Lubchenco, Undersecretary of Commerce for Oceans and Atmosphere and Administrator of NOAA, Martin Jeffries, Program Officer and Arctic Science Advisor at the Office of Naval Research in Arlington, Virginia, Donald Perovich, Adjunct Professor at the Thayer School of Engineering, Dartmouth College, and Jason Box, Associate Professor, Department of Geography at the Byrd Polar Research Center at the Ohio State University, Columbus, Ohio. Dr. Lubchenco will begin the press conference.
Thank you very much. Hello, everyone. Thank you for being here as we present the annual update for the Arctic Report Card. This Arctic Report Card is sponsored by the Arctic Research Program in NOAA's Climate Program Office. It began in 2006 just because scientists were seeing very dramatic changes in the Arctic and thought it would be useful to have an annual synthesis and reporting of those changes. This benchmark by which changes could be evaluated was clearly a good idea, and we're seeing the benefit of that today. This year, we had a record 140 scientists from 15 nations participate in this report card. So it really is a remarkable effort, and I want to take this opportunity to thank everybody who was involved in it. The editors did a magnificent job of coordinating everything. Clearly, many nations are interested in what happens in the Arctic, and I think that's for good reason. What happens in the Arctic doesn't always stay in the Arctic. We're seeing Arctic changes in the ocean and the atmosphere that affect weather patterns, for example, here in the United States. We know that melting of ice in Greenland can contribute to sea level rise around the world. And many of the biological changes that we are seeing underway sometimes affect biological systems elsewhere, for example, through migratory birds. NOAA has a very robust presence in the Arctic. This is one of the things that we are helping to coordinate, but we, and along with other partners, are very active in the Arctic. NOAA's special responsibilities include providing science services and stewardship, for example, services like weather forecasts and warnings, like we do in the lower 48, but also ice forecasts, hydrographic services and geodesic services, monitoring climate and other changes, managing fisheries and protected mammals and other endangered species, and simply promoting healthy oceans and coasts. You'll hear in more detail shortly that conditions in the Arctic are changing in both expected and in sometimes surprising ways. Last year, the Arctic saw warmer waters and record low levels of sea ice and snow. And these physical changes are in turn triggering biological changes, more above ground biomass on land, but also lower levels of production, biological production, especially at the low in the food chain in the Arctic Ocean. So again, I want to thank all of the participants in this report card. And acknowledge how important it is to be working together to document and understand these changes because they have global ramifications. So I want to turn it now over to Martin Jeffries, one of the 3 editors of the report. Martin?
Thank you, Jane. Good morning, everyone. As you know now, I'm Martin Jeffries. I'm one of 3 editors of the Arctic Report Card. I'm also a Program Officer and Arctic Science Advisor at the Office of Naval Research, and I'm also a Professor of Geophysics at the University of Alaska. I'm on leave working for the federal government. I'm very pleased to welcome you today to the official release of the 2012 update to the Arctic Report Card. My thanks to Dr. Lubchenco for her introductory remarks, and also my co-editors, Jackie Richter-Menger of the Cold Regions Research and Engineering Lab in Hanover, New Hampshire, and Jim Overland of NOAA Pacific Marine Environmental Lab in Seattle. Also on the panel today are Dr. Jason Box of the Byrd Polar Research Center at The Ohio State University, and Dr. Don Perovich who's an adjunct professor at Dartmouth College in Hanover, New Hampshire. They will be talking specifically about Greenland and sea ice, respectively. Before we describe some of the highlights of the report card and take your questions later, let me give you a little bit of background about this web-based publication. It's sponsored by the Arctic Research Program in the NOAA Climate Program Office, and it's the 6th annual update to the report card, which was first published in 2006. This year's report, as Dr. Lubchenco said, is the work of a large international team of scientists. A record 141 authors from 15 countries prepared 20 essays describing the state of different components and key indicators of the Arctic environmental system. The essays are organized into 5 sections: atmosphere, sea ice and ocean, marine ecosystem, terrestrial ecosystem, and terrestrial cryosphere. The Circumpolar Biodiversity Monitoring Program of the Conservation of Arctic Flora and Fauna, or CAF, working group of the Arctic Council was instrumental in soliciting many of the ecosystem essays in the report card. All 20 essays were subject to independent peer review that was organized by the Arctic Monitoring and Assessment Program of the Arctic Council. And I'd like to thank CAF and AMAP for their very important contributions to this year's report card update. Key highlights from the essays are presented on the front page of the website, and as you see here on the screen, which will be live soon on the web. You'll also find a video on the front page that summarizes the report card if you like pictures and words in that fashion. So, what do we have to report about the Arctic in 2012 in the 2012 update to the report card? A key feature of 2012 was that, with the exception of 1 or 2 episodes, Arctic-wide air temperatures were unremarkable in the context of the last decade. Yet, there was continuing significant change in the cryosphere, our frozen world, our frozen realm, which saw new records for low snow extent in spring, low sea ice extent at the end of summer, extended duration and vast extent of melting at the surface of the Greenland ice sheet, and high permafrost temperatures. Excuse me a moment. So Jason, would you tell us what's been happening on the Greenland ice sheet and what's reported in the report card, please?
Thanks, Martin. I've studied Greenland for 20 years now. I've devoted my career to it, and 2012 was an astonishing year, especially in summer. And I'd like to preface my statement with this was the warmest summer in a period of record that's continuous in 170 years. The warmest summer in 170 years. So in 2012, Greenland ice sheet changes accelerated. We have evidence of not just an increase, but an acceleration in surface melting, ice area loss, and volume losses, contributing to sea level rise in an accelerated way. The duration of melting in summer 2012 was the longest in the period of observations since 1979. So extensive surface melting was documented for the first time at the highest elevations of the ice sheet. This extensive melting was actually promoted by a persistent atmospheric circulation anomaly. It's been 6 years in a row now that there's been a lot more southerly air heating the ice sheet. And this is measured by a strong negative North Atlantic oscillation, which typically not examined in summer, but we notice in summer that it's a strong negative NAO. Consequently to this enhanced melting, the reflectivity of the ice sheet reached an all-time low in a shorter period of observations, continuous since 2000. That's about a 7% decline in the reflectivity of the ice sheet in summer, that produces an increase in energy absorption that's about twice that of the annual energy consumption in the U.S. The ice sheet's absorbing that much more energy. And because reflectivity, that heating, it's part of a self-reinforcing feedback that takes away cold content from the snowpack, so that in following years, it's easier to melt the ice sheet. Part of this circulation pattern, again, persistent since 2007, is high pressure over the ice sheet, which promoted clear sky conditions, maximizing solar energy, and given that the surface of the ice sheet was darker in color, and all that extra sunlight maximized the impact of melting. We're also looking at the marine terminating glaciers, these outlets to the inland ice sheet reservoir, and they lost collectively, the 40 largest glaciers lost an area about twice that of the previous decade average. The volume changes measured by the GRACE satellite indicate that for the year 2012, the summer, the largest volume of ice loss rate, largest mass loss rate, the largest sea level contribution in 2012 in the period of observation since 2002. And remarkable about the ice volume changes in the most recent 4 years, that's at twice the rate of the first 4 years in this record, and it suggests a loss rate for the ice sheet, a doubling time of the loss rate of the ice sheet of 10 years.
Okay, thank you very much, Jason. The essential ingredient of an ice sheet or a glacier or an ice cap, of which there are many around the Arctic, that essential ingredient is snow. Adjacent to the glaciated regions, snow covers the land surface for many months each year. But there's strong evidence that the areal extent of the snow cover is declining rapidly at a critical time of year, that is in the spring, and more specifically in May and June. Successive records for the lowest June snow cover extent have been set each year since 2008 in Eurasia, and in 3 of the past 5 years in North America. And it's noteworthy that the rate of decline in June snow extent has decreased at a more rapid rate than the decline in the snow cover, in the sea ice cover, and sea ice extent, during the same period. Snow is a highly reflective material, as anyone who's been out in the snow without sunglasses or sunscreen will know. The loss of spring snow cover is critical because it exposes the darker, less reflective land surface earlier to solar radiation. That is, to the sun and its warmth. And that's something that Jason just alluded to with respect to the changing reflectivity of the Greenland ice sheet. This same issue of changing or declining reflectivity and absorption of solar radiation also applies to the Arctic Ocean, where the sea ice is also declining in extent and exposing darker ocean surfaces. And Don will now say a few words about what happened to the sea ice cover in 2012.
It was an eventful year for the Arctic sea ice cover. At the end of winter in March, the overall extent of the ice cover was relatively large, and there was a particularly extensive ice cover in the Bering Sea. But all this changed during the summer melt season. From March to September 2012, we witnessed the largest decline from the late winter maximum to the late summer minimum of sea ice extent observed in the 33-year record. This culminated in September in the smallest ice extent ever observed, that was less than half of the average value between 1979 and 2000. August 2012 was a period of exceptionally rapid ice decline, with large losses occurring in the East Siberian and Chukchi Seas during an intense storm in early August. The past 6 years have had the 6th smallest September ice extents since observations began in 1979, showing that the Arctic sea ice has not recovered from the large and unexpected decrease that was observed in 2007. The shift from older, thicker ice to thinner, younger ice continued. This continued decline in sea ice is indicative of a shift to a new state of reduced sea ice coverage. This new state of the sea ice cover has implications for other components of the Arctic system, particularly the marine ecosystem and even the terrestrial ecosystem.
Thank you, Don. Sea ice is a vital component of the marine ecosystem, and as the ice has retreated and the age, a proxy for ice thickness, has decreased, unexpectedly large phytoplankton blooms have been observed below the ice in the summertime. Consequently, it's been suggested that previous estimates of annual primary production, that is productivity at the bottom of the food chain, those previous estimates may be 10 times too low based on recent observations and measurements, primarily in the Chukchi and Beaufort Seas. Primary productivity is also increasing on land. The tundra, immediately adjacent to the expanding area of open ocean in the summer, is seeing an increase in biomass, in greenness, in the length of the growing season, and in summer warmth. The combination of greater summer warmth following an earlier retreat of the snow cover in spring is probably a factor in the increase in permafrost temperature below the tundra land surface. For example, in 2012, record high temperatures were recorded at 20 meters below the surface, that's 60 feet or so, below the surface at 8 of the 10 permafrost observatories that have been monitored on the North Slope of Alaska annually since 1983, 30 years. At the other 2 observatories, where there wasn't a record this year, the temperature was the same as it was in 2011, when there was a record set. Permafrost and snow are integral components of the tundra ecosystem. One of the keystone species of that ecosystem, the lemming, a small rodent with a bad temper and sharp teeth, is also showing signs of change. There's evidence that the previous roughly 4-year regularity of the lemming cycle is decaying, meaning it's lengthening. So the peaks and troughs, the distance, if you will, in years is increasing between peaks or between troughs in the cycle. Moreover, the amplitude of the cycle has collapsed in some places, such that the population densities are very low now in some regions. A link between changes in the lemming population cycle and changes in the characteristics of the snow cover, such as was reported a moment or two ago, has been suggested. One animal that's directly affected by changes in lemming populations is the Arctic fox. In Europe, the Arctic fox population has declined to near extinction due to failure to recover from overharvesting in the early 20th century, plus the changes in the lemming cycle. The Arctic fox remains abundant in North America, but here and in Europe, the larger red fox has been expanding its range northward, leading to predation on and competition with the Arctic fox for food resources. So, those are a few of the highlights we have time to share with you today. So how would I sum up the current state of the Arctic? First, multiple observations provide strong evidence of widespread, sustained changes that are driving the Arctic environmental system into a new state. A major source of the momentum for this rapid transition is the combined effect of the changes being observed in the snow cover, in the sea ice, glaciers, and the Greenland ice sheet. Those very visible components of the cryosphere are conspiring to reduce the overall surface reflectivity of the region in the summer when the sun is ever present. In other words, bright white surfaces that reflect summer sunlight are being replaced by darker surfaces, such as the ocean and the land, which absorb sunlight. This darkening of the surface increases the capacity to store heat within the Arctic environmental system, which enables more melting, which we call a positive feedback, or as Jason referred to it earlier, as a self-reinforcing cycle that feeds on itself, essentially. This explains why the Arctic continues to grow warmer by a factor of 2 more than the lower latitudes. The rate of change in temperature, the rate of increase in temperature in the Arctic is twice that at lower latitudes. And this is what we call the Arctic amplification of global warming. A feature, a phenomenon that was predicted 30 years ago and which we're now seeing happening in a significant way. Second, we're seeing profound changes in both the marine and terrestrial ecosystems and increasing evidence of strong connections between those ecosystems. For example, the increasing duration of open water and the decline in summer sea ice extent in the Arctic Ocean are, one, affecting marine primary productivity, namely the abundance and composition of phytoplankton communities at the bottom of the food chain, and two, for example, contributing to greater summer warmth in the tundra regions where primary productivity is increasing and peak productivity is occurring earlier in the season. In conclusion, if we're not already there, we are surely on the verge of seeing a new Arctic. We can expect to see continued widespread and sustained change with new record highs and record lows, depending on the variable you're looking at, throughout the Arctic environmental system. And since the Arctic is not isolated from the global environmental system, indeed it's an integral and vital part of the global environmental system, we can expect to see Arctic change have global environmental and socioeconomic consequences. So that concludes our update to the Arctic Report Card for 2012. I thank you for coming, and I'll now open the floor to questions, and we will try to answer those. And we will do that with the assistance of a number of Arctic Report Card authors who are in the room. If you could just raise your hand, that might be helpful. And we have 4 people, editors and authors, who are also on the phone. So we have quite a cross-section of the team of editors and authors in the room, and we will now answer any questions that you have. Thank you.
Yeah, Dr. Jeffries, I'm David Perlman from the San Francisco Chronicle. A couple of logistical questions. Your summary, which obviously you were reading, is that available?
It will be available on the website to download, yes.
I beg your pardon?
It will be available at the Arctic Report Card website for download.
Oh, okay, fine. And I assume the website itself is available?
Yes, it should be live now.
Okay.
Or
now,
very soon.
Having disposed of that, I do have a question. There's been a lot of controversy over the extent of sea ice and its implications in the Arctic. Could you summarize for us as you did in your reading, what that implies for the state beyond the Arctic? Because the Arctic itself, I assume, is something of a driver for the rest of the world. Could you summarize that? How does that reflect what's going to happen or has happened in the non-Arctic area of both Europe and America?
Well, I'll begin to answer that, and then I'll defer to, say, Jim Overland from NOAA PMEL, who can talk expertly about other aspects of that. But part of the importance of the changes in the ice cover goes back to what we've emphasized here in the press conference so far, is the fact that as you lose the ice cover in the summer, then you're changing the overall reflectivity of the Arctic basin because you're exposing darker ocean to the sun, which leads to warming of the ocean, which leads to more melting of the ice. On a global scale, that's important because that's changing the global reflectivity. And it's basically, the Arctic acts as a thermostat for the global climate. It's a heat sink. And by changing the reflectivity, we're changing that thermostat, and the Arctic's control or contribution to the operation of the global climate system. Jim can talk more about how this affects, for example, atmospheric circulation and temperatures at the mid-latitudes.
Jim Overland, NOAA. The heat that gets stored in the land and the ocean, the largest temperature anomalies in the northern hemisphere in these ice-free areas of 6 or 7 degrees creates a bubble of warm air that changes the winds locally. We definitely know that that part is very strong as the panel has come. The impact of that added heat on the planet does influence mid-latitude weather and storms. Rather than the normal jet stream going just straight from blowing from west to east, creates a more wavy pattern that can create paradoxically more cold and snow at mid-latitudes. The difficulty from a forecasting point of view is the weather at mid-latitudes is very chaotic. So you have this strong forcing in the Arctic interacting with the chaotic weather at mid-latitude. So even though the forcing from loss of ice and snow is the same every year, so far the impacts in snow and ice have been different every year. And so that's a big area of research, and it's a big area of controversy on just how much impact there is.
Hashtag Washington Post. Could you talk a little bit about, you say there's this added productivity in the phytoplankton and the biomass. Make the connection. What does that mean for the ecosystems up there if there's more plankton early in the season, if there's more moss or whatever there is on the tundra early in the season? What impacts does that have?
Don, or is Karen Frey in the room? Is there anyone from the report card team who would like to comment on that?
I can talk about that a little bit. I think what we're seeing is that to get these phytoplankton blooms, you need 2 things, nutrients and light. And the nutrients have always been there, but in the older Arctic, with the thicker ice, there was very little light transmitted. But in this new state that we've gone to, you have thinner ice that has more surface melt features on, so the amount of light transmitted has increased from just a few percent to 30 or 40%. And now there's ample light to start these phytoplankton blooms. How that's going to connect to the food web is still uncertain. We've just been seeing these blooms in the past few years, and they're very productive, extremely high productivity, but how it will connect to the rest of the food web is still unclear.
Steve Benka, Physics Today. I have a question for anyone on the panel or any other experts in the room. There are some reports about geoengineering. Oh, that's not working. Okay, I'll start over. Steve Benka, Physics Today, for anyone on the panel. There are some reports of geoengineering efforts or attempts or proposals in the Arctic region, specifically to increase the albedo, the reflectivity, in the clouds. I've heard of one proposal and another on the surface of the ocean. What impact, if any, could such efforts have? Well, and how seriously are they taken? And given the rapidity of the change and the momentum behind the change going on in the Arctic, what impacts, if any, could such efforts have?
I think the answer is we don't know what those efforts will do, what the impacts will be, and that's why these efforts are the subject of research. That no one's talking about actually implementing such a thing anytime soon, but there is talk about the need to investigate what the consequences might be. Will the intuition, if you will, actually be realized, and the hope be realized that they could increase reflectivity and decrease temperatures and melting and so on. I know of one report, it was a European project, I think in the UK was the main location, University of Edinburgh, I think, with an idea to basically spray seawater high into the atmosphere. That caught the attention of the media, as I recall, and there was a lot of discussion about that just earlier this year, I think. That's one example that is actually directly aimed at the Arctic issue, I think. Yeah. But they're very much topics for research. The people who are putting forward these ideas recognize that this is a controversial area and it requires a lot of research to be confident, have any confidence in these methods for ameliorating climate.
I think if you look at snow and ice, they're not just good reflectors, they're great reflectors. And what we've seen in our presentation is snow is melting on land, on the ice sheets, sea ice is melting, and really the Arctic is one of the Earth's reflectors. It's one of the Earth's mirrors, and that mirror is breaking. So there's a tendency to look at solutions that can impact the albedo. But I think there's two major challenges. One, that we recognize the Arctic is a system of interconnected components, but we don't really fully understand how that system works. And so if you start to mess with the system, it's like when I work on my car. You're not really quite sure what will happen. I think the second challenge is scale. If we were just looking at a small scale thing, we could probably come up with something, but this is an enormous area. You know, the sea ice cover at the end of summer alone is on the scale of the United States.
You mentioned the professor of engineering. He's a department member of our group. And what we're trying to do is to investigate how much cooling power we require and could this be supplied by geoengineers. We've done a calculation of the cooling power required to offset the heating that's currently happening due to the albedo change. Is in the order of 0.4 gigawatts, which the question was asked to
Harvey Lyford, freelance. I have a question on the...
I am here, and I give you information. We are launching a strategic plan to explain how we can get out of the difficulties caused by these sea ice precipitous blocks.
Thank you for that. If there are any questions, we'll continue.
Yeah, Harvey Lyford, freelance, front row. Nobody mentioned the megafauna of the Arctic, polar bears, narwhals, walruses. I presume they're in the report. Can somebody just briefly summarize what it says about them?
There is an essay about caribou and reindeer that in this year's report card. Polar bears are not discussed in this year's report card. They were in last year. We can't cover everything in the press conference. We can't cover everything in an annual report card. As Don said, the Arctic system is very large and very complex. But I encourage you to go to the report card itself online and look at the reindeer and caribou essay, which, if I was to summarize, it says that some of the populations are healthy and increasing, some are sort of not so healthy, maybe declining, some are just moving along in sort of steady state. It's very variable around the Panarctic region. Trying to attribute the causes for these variations in populations such as caribou and reindeer is a challenge because certainly in Europe and Eurasia, those populations are the subject of animal husbandry. And they're not, some of them are not entirely natural populations. They're quite heavily managed, as opposed to some of the natural, unmanaged populations that elsewhere in Europe and North America. So there's no clear picture with caribou and reindeer. But please take a look at the essay in the report card.
Yeah, Martin, it's Michael Sobota here in Whitehorse with Environment Canada and the Circumpolar Biodiversity Monitoring Program. I'd only echo what you said earlier to summarize with respect to caribou, saying that many of the herds that had experienced declines over the last decade are finally showing signs of stabilizing and increasing, and that's with and that's highlighted in the caribou essay.
Thanks, Michael.
David Hirsch.
If I can add, it's Mike Gill, also with the Circumpolar Biodiversity Monitoring Program. There is some information also on whales in the report cards. For instance, the recent sea ice declines we think are attributed to gray whales staying longer in Arctic waters to feed. I think maybe the more important thing here is that while sea ice retreat has been maybe the most famous indicator of a changing Arctic, it's only recently that we've started to be able to detect some meaningful biological response to this changing Arctic, and I think a lot of that is due to the fact that there's a number of international integrated efforts to detect change. Another example of a biological response to the changing Arctic is with seabirds. We are seeing some changes in diet and also timing of initiation of breeding in some seabird species that we believe is in response to changing marine conditions.
David Hirsch with NHK Television. Two questions. First, Dr. Box, you talked about this high pressure over the ice sheet in Greenland since 2007. Dr. Overland talked about chaos more in the mid-latitudes. But I'm wondering, is there a connection there? Is this kind of high-pressure system in some way, it's kind of an anomaly, as you said, but is it a reaction to some sort of Arctic change? And secondly, oddly enough, I think my second question was being answered off mic, which was, is there a way of quantifying this issue of ice albedo, this kind of loss of reflectivity and kind of increased absorption of energy? How do we as reporters quantify that? Is there a measurement of some sort that we could attach to that?
Well, the second question, the Greenland ice sheet is absorbing in more energy that's equivalent to twice the U.S. Electricity consumption each year. So just in the last 10 years, the ice sheet's taking on another more than 100 exajoules of energy. That's twice the U.S. energy consumption. The first question, I asked that to some of the other authors of the report card, trying to get at a trigger mechanism. Was it the 2007 step down in Arctic sea ice that has stayed at this declining level of sea ice? Was that the trigger? And I think what we arrived at in that conversation, I spoke with a number of the authors just before this conference, is it seems that it's actually the terrestrial snow cover, because it's melting off sooner than the Arctic sea ice, and it's kind of leading the effect. And Arctic sea ice then has its minimum later in the summer. But really, all of these effects are working in a complex way together. Then in Greenland, what's occurring, because the ice sheet is so high in elevation, it anchors an atmospheric circulation that when there's more vigorous circulation, it would just blow on through and be more of a transient wave, but the wave gets locked on the Greenland ice sheet, and that just pumps heat up from the south along West Greenland, and for now 6 summers in a row has produced this strong melting. But it does appear to be connected to a broader change, perhaps led by terrestrial snow cover reductions, but also related to, again, sea ice. And I'd encourage you to speak with the snow cover and other authors to try to make sense of that complex question.
I have 2 questions from our web chat. The first is from David Kramer with Physics Today. Some scientists are predicting that summer sea ice could disappear from the Arctic Ocean as soon as 2015. Is this view widely held? What are the implications of the rapid loss of ice for the release of methane from the seabed?
Well, I guess I can address part 1. Yeah, there have been estimates of when will all the summer sea ice be gone. They range from a few years to a few decades. I think if you try to put a number on that, what's the most common number, it's usually in the 2030s, not just in a couple of years, but in a couple of decades. I think one thing to look at is, in some ways, this is the most complicated time for the Arctic sea ice cover. If you go back 25 years, you could pretty much say in the summer the Arctic basin was full of ice. If you go ahead 25 years, you can probably say if things continue, the Arctic basin will be pretty much empty of sea ice. But right now, it's kind of a mix, half ice, half ocean, and it becomes important to know what, and very difficult to predict, what's it going to be next year. How much ice will there be, and what will be the spatial distribution of it? So it's really a difficult time now. Methane.
If I could make 2 comments. So, on the question of an ice-free Arctic Ocean, I always feel it's very important to point out that we're talking about possibly a summer ice-free Arctic Ocean. The temperatures for the foreseeable future in the winter are always going to be cold, and there will be sea ice in the wintertime. Nonetheless, the fact that there might be an ice-free summer is very important, obviously. On the methane question, greenhouse gases question, Laurie Bruweiler from NOAA is in the room, and I wondered, Laurie, if you'd care to comment about the question on the release of methane from the seafloor, if you're still here. I guess she's not here any longer. So I can say a few words about that. Obviously, it is a concern. It's an issue that's been raised that the release of greenhouse gases, both from the land, from the tundra, and also from the ocean seabed, could amplify Arctic change because we now have a regional source of greenhouse gases being added to those being injected into the atmosphere globally and transferred by the atmospheric circulation to the Arctic. There have been recent reports, and by recent I mean in the last 2 or 3 years, of significant venting of methane from the East Siberian sea shelf, and that generated a lot of interest and debate as to whether this was a new thing or had it been going on all the time, but it just been discovered simply because finally it was possible to get a vessel in there to investigate the ocean chemistry and the gas content and so on. I seem to recall that the greenhouse gas essay says that there is currently no evidence to suggest that greenhouse gas releases from Arctic sources are contributing to the amplification of warming in the Arctic. That's not to say that that will stay that way, but the greenhouse gas scientists, their measurements indicate that greenhouse gases coming from Arctic sources are not adding to the warming in the Arctic at this time.
And the second question from the internet is from
excuse me, before we do that,
sure.
I just wanted to add one quick thing to what Donald said about the first part of that question, and that is just to emphasize a couple of points, one of which is a lot of people have talked about an ice-free Arctic, but the language that I think is actually more appropriate is an ice-diminished Arctic. I think that's more accurate. The second point is that not all ice is the same from a biological standpoint in particular, but also from a physical standpoint. And that multi-year ice, which is what has characterized the Arctic in times past over vast areas, is very, very different in terms of its ability to support biota both on top as well as on the underneath surface, and in terms of the amount of light that is transmitted through it, than is the annual ice that we're seeing with increasing frequency in the Arctic, even during the wintertime. So just those 2 points to amplify what I think Donald was talking about.
Okay. Our next question is from Seth Borenstein of the Associated Press. One more for Dr. Lubchenco. This has been an unusual and extreme year for weather in the U.S. How bad has it been in your mind, and how connected is it to what's happening in the Arctic?
We are seeing every year is bringing different types of extreme weather and climate events. This last year, we have certainly seen extreme events in the United States, for example, with a very, very prolonged drought. We also have recently seen a very significant disaster with Superstorm Sandy, affecting significant portions of the eastern seaboard, especially New York and New Jersey. I think that the jury is still out with respect to the relationship between Superstorm Sandy and climate change. I think what scientists would all agree on is that all storms today are happening in a climate-altered world. And one of the analogies that I find compelling is that with baseball and use of steroids. Many of you have heard this, but I think it's a useful analogy that any particular baseball player who is on steroids has a much greater probability of hitting lots of home runs. That doesn't mean that you can say that any particular home run is due directly to use of steroids, just that there is a much greater likelihood that there will be lots and lots of home runs. And so as scientists work through the attribution issues, I think the most appropriate thing for everyone to be cognizant of is that storms today are really taking place in a climate-changed world, and that, that's just the world that we are in today. The extent to which we can connect the dots between all of these phenomena that are in the report card and those extreme events, I think, is also a very active area of investigation, so stay tuned.
Okay, Larry O'Hanlon with Discovery News. You said earlier, I can't remember exactly who it was, but that the Arctic is entering a new state. I know there's all these different positive feedbacks going on, and it's an ongoing thing. But is there any idea what that new state will be? I mean, once the ice, we're talking about a phase change of water as a big part of this in the Arctic. Is there any idea when it stops, when it stabilizes? Any idea like that?
Do you care to comment, Jim?
Yeah, that's. Could we have a microphone down in front, please? Thank you. Over here. Thank you.
The last few years, there's been a talk about a tipping point, and the question there was, would we hit a minimum ice and increasing temperature where we would have a runaway situation, a loss of ice and increased temperature. What it seems now is that we have a modest increase in greenhouse gases that gets amplified with this Arctic amplification in the Arctic. So the temperature increases are much more, and then we have the cascade of all the indicators that they've talked about. But the best understanding is that that is driven by the long-term increase in greenhouse gases, and that we will continue to get changes with Arctic temperatures of 6 degrees warmer by the end of the century if we keep up the increase in greenhouse gases. The good news is if we stabilize greenhouse gases, it looks like the changes that we're seeing in the Arctic will also stabilize. But right now, the loading of CO2 we have, what's in the pipeline for the next decade or so are going to continue an increase in all of these changes, at least for the next few decades.
I'd like to add something for Greenland on that point, that in 2012, Greenland crossed a threshold where we saw for the first time complete surface melting at the highest elevations, what used to be called the dry snow zone. But there was widespread melting across the ice sheet. And because of this self-reinforcing feedback, we should expect Greenland to be melting across its complete surface in the coming decade. Perhaps not next year, but I would say very likely if the Arctic remains in this low snow cover and low sea ice state. So as Greenland crosses this threshold and starts really melting in its upper elevations, it really wouldn't recover from that unless climate cooled for significantly for an extended period of time, which just doesn't seem very likely going forward.
And if I could just add one more point, we've been talking about going for a nearly sea ice-free summer, but in many cases, what's most important is how many months will you be sea ice free. So we'll start with September, but it could go to several months. And the upside is that increases the access to the Arctic in terms of resources and shipping and so forth. But the impacts on species such as walrus and polar bears that depend upon sea ice, they can probably handle a 1 month loss of sea ice cover habitat, but if it got up to 3 or 4 months, then they would be in more trouble. So, yeah.
Thank you, and with that, we're going to end this press conference. Our next press conference starts at 1:30, talking about natural or man-made triggers to induce earthquakes. Thank you.
Thanks, guys.
Thanks.
Nice to meet you, Tracy.
It's been fun.